Okay, so we're done for introducing you the L'Hopital rule, because we will use the L'Hopital rule for solving the improper integration in this section. Okay, this is our main contents. Okay, we divide the case or the problem into two different problems. We have a type 1 and type 2. Okay, doesn't matter about the number, it's just the way we want to separate the problem. Okay, what is the type 1? Type 1 here, okay, look at the integration here. Why we call this improper integral? Okay, why? And because there are two problems here. So type 1 for the problem number 1, meaning that one or both limits are infinite. Okay, what does it mean? Meaning that, okay, now you want to integrate the function with respect to x, and then maybe your limit, you want to evaluate the limit from specific value a to infinity. Okay, or maybe you have the other case, the function, and then you want to find the limit where we have a very very small value but we do not know, so you can just put negative infinity to b, for example. Or there are situations where both of your limits are infinity, fx dx in negative infinity to positive infinity. So this is belongs to the case of type 1. How about type 2? Type 2 is, look at type 2 because number 2 here. Okay, type 2. Type 2, the function itself, the problem is coming from the function, not the limit. The limit are okay, they are all number a, b, but the problem with the function. For example, you want to integrate 1 over x minus 2 with respect to x, and then you have you want to calculate the x from 0 to 2. So look at the limit here, they're just okay, right? 0 and 2, they are definite value, I mean something real number. Okay, now look at the function itself. Is the function is continuous at all value of x from 0 to 2. Okay, now check 0. So you substitute 0. So you got 1 over minus 2. It is a number, right? The answer will be a number, even though it is negative. And then we check for 1. X equal to 1. Because 1 is in the range of the limit, right? X equal to 1. So you got 1 over 1 minus 2. So you got negative 1. Also a number. The function will give you a number. How about 2? What happens if you replace x by 2? So we got 1, 2 minus 2. So we got 1 over 0. Okay, try you calculate using your calculator. What the calculator will give you? 1 over 0. You can see the math error, right? This one, because of there is no value. The value does not exist. It is not real. So we can say that the function f of x is not continuous at x equal to 2. Continuous here meaning the value cannot be found. The value does not exist. So that's why it's become improper, something not proper. Okay. So because of the problem is coming from the function itself, so we call this as a type 2. Okay, or maybe you can find the function. Okay, I'm using the same function, x minus 1. Okay, for example, with respect to x, and your limit is 0 to 3. Okay, so now we check whether the function can be evaluated at all x from 0 to 3. Okay, we check 0. The smallest is 0. So we replace x equal to 0. We can get a number, is it? And same goes when we replace the highest value 3, we still get a number. But did you realize what happened when we have x equal to 1? When x equal to 1, so now your limit 0 to 3, it is okay, but there is a problem when it is at x equal to 1. Because why it is a problem? Because when you replace x equal to 1, you will get something 1 over 0, where the function cannot be found at x equal to 1. So this is also another case that you will see later. Okay, so that is the introduction of the improper integral before we proceed with the example.